All right, lesson 46 is simplifying basic square root expressions, and we're going to add into this lesson simplifying higher order roots. We'll talk about cube roots, fourth roots, other things, and some alternate ways of expressing those things. Now, the first few examples that we're going to look at here are really simple. Just reviews of basic square roots of numbers. We talked about this in our bell work today. And so let's just dive right in and have a look at it. What we reviewed and talked about already is that the principal square root, which is asked for by this symbol, is the positive square root of a number. It's only the positive square root of a number. If no negative sign is present, okay, the principal square root is what is being asked for. So the square root of a number, the square root of 25, for example, is just 5. Now, 25 has two square roots, but this symbol is only asking for the positive square root of that number. All right, so we kind of got to make sure that we reiterate that to kind of correct some incorrect understandings from before. All right, so what is this asking us for? Just 8? Yes, just 8. You need to be sure of that. This is only asking us for the principal or the positive square root of 64, which is 8. What about this? What is this asking for? This is asking us for the negative square root of 9. This is the other one, right? We've got the principal square root. This is the negative square root, and that would be negative 3 is correct. So the negative square root of 9 is negative 3. All right, what about the square root of 0? 0, right? This is the only exception to the rule. But 0 is unique because 0 only has one square root, right? Just 0. Every other number has two square roots. What is this asking for? The negative square root of 4/25. What is the negative square root of 4/25? It is negative 2/5. All right, because this is asking us for the negative square root, we're guaranteed that we're going to have a negative answer. The negative square root of a number is negative. The principal square root is positive. What about this one?
It's an imaginary number.
It's not really a trick question, but does negative 36 have a square root? Not a real square root. Okay, remember when we were dealing with our number theory at the beginning of the year, the imaginary numbers, the complex number system is divided into real numbers and imaginary numbers. The real numbers are the square roots of all the positive numbers, and the imaginaries are the square roots of all the negative values. Okay, so we've got, this is an imaginary number. Okay, it's not. Here's what I would want you to write: not a real number. Okay, if you run across this on a test question or a quiz question, this is not a real number. The answer is 6i. Okay, that's the imaginary value. All right, now higher order roots. Now let's talk about this for a second. We've already dealt with this. The cube root is a number that can be written as the cube root of x. That index, the 3, the index on the radical, tells us which root to take. This is asking for the cube root. Now we could do the cube root of x. We could do the fourth root of a number. You can do any root of a number. You can do the seventh root of a number. Okay? The seventh root of 128. It's 2. Is that right? Is 2 to the 7th equal to 128? 256 is the 8th. Yes. Yeah. So this is 2, right? Because 2 times 2 times 2 times 2 times 2 times 2 times 2 is 128. So this is asking for which number multiplied by itself 7 times is equal to 128, and the answer is 2. All right, so what would the cube root of 64 be? Why? Because 4 cubed is 64. 4 times 4 times 4 is 64. All right, what about the cube root of negative 8? Is it? Hadley, it is negative 2 because negative 2 times negative 2 times negative 2 is negative 8. Now, this is a rule. Y'all listen to this rule. It's okay for the odd index of a negative number. We can take the odd index, cube root of a negative number, fifth root of a negative number, seventh root of a negative number, ninth root of a negative number. We cannot take the even root of a negative number because you can't take an even number of negative signs and get something that's negative. Because negative times negative is positive. All right? So what about the fourth root of 81? Why is it 3?
Because 3 times 3 times 3 times 3 equals 81.
Because 3 to the fourth is 81. That's right. What about the fourth root of 160,000?
I'm going 40. It's 400. No, it's 40. It's 400. 40 over 8. No, it's not even 40.
No, it's 40.
It's not even 40. It's 20. It's 20. It's 20 or 200.
It's 20, right? Because 20 to the fourth power,
2 times
2 to the fourth is 16.
Not 4.
Right. 4 to the fourth is 256.
Yes.
All right. So 20 to the fourth power, 4 zeros kind of tells us that we have 1 0 in our original problem. All right. The fourth root of negative 1, it's not a real number. It's something. Remember, nothing is reserved for very specific things in mathematics. This is not a real number. Now, what we're going to throw on you today that's new is fractional exponents. So, those of you who quit taking notes, you need to jump on this. All right. Consider this expression x to the 1/2 squared. What would you do to those exponents using the power property? You would multiply them, right? X to the 1/2 squared simplifies to x. And look at this. Isn't the square root of x squared also equal to x? The square root of x squared, the square root of anything squared is just what's inside. So this leads us to this fractional exponent thing down here at the bottom, and I'm going to rewrite that a little larger. What that says is the nth root of a number b can also be written as b to the 1 over n power. So we can use fractional exponents to show roots. Fractional exponents are roots of the number. So the 1/2 power is the square root. The 1/3 power is the cube root. The 1/5 power is the fifth root of a number. All right, so 216 to the 1/3 power is really asking us for what? This is asking us for the cube root of 216, which I've challenged you guys to know your cubes up through 7. 6 cubed is equal to 216, so the cube root of 216 is 6. All right, what about negative 27 to the 1/3? What is that asking us for? It's asking us for the cube root of negative 27, and that is negative 3. It's okay to take the odd root of a negative number. All right, what about the fourth root of 10,000? It's 10, isn't it? Isn't this 10 to the fourth? How many zeros does it have? So that's 10 to the fourth. So the fourth root of 10 to the fourth is 10. Yeah. All right. What about the fourth root of negative 256? It's an imaginary number. It's not real. Okay? It's not real because you cannot take the even index or the even root of a negative number. It would not be 4i. That might be one of them. No, it's not. 4i is not a square root there. This gets real complicated. You have to use trig and some other stuff to find there's actually, just like there's 2 square roots of every number, guess how many cube roots there are of every number?
3.
3. Okay. For example, 8 has 3 cube roots. One of them is real. The cube root of 8 is 2. 8 also has 2 imaginary roots. And this goes back to the fundamental theorem of algebra. Every nth degree polynomial has how many solutions? N solutions. So if I'm looking at a simple polynomial equation, for example, if I'm looking at a simple polynomial equation like x cubed equals 8, how many solutions does it have? 3, because 8 has 3 cube roots. All right, if I had a few extra minutes, I would show you what they are. X squared equals 4 has how many solutions? 2. 2. What are they? Positive or minus 2. And this is where teachers get confused and tell you the square root of 4 is plus or minus 2. That's not true. X squared equals 4 has 2 solutions plus or minus 2. A little later in the class, I'll show you where the 2 solutions come from, but it's not because the square root of 4 is plus or minus 2. All right? Okay, so the shape of a box has a volume of 3375 cubic inches. What is the side length of the box? How would you do that?
You would take the cube root.
You'd take the cube root of 3375.
Which I don't want to do.
That's probably going to end in 5, wouldn't you think? Maybe 15. Maybe 15, maybe 25. I'll leave that one up to you. Write this down. All right. Now, I am out